At the edge of industry, forgotten wood begins its second life.
Every board, pallet, and splintered plank is recovered from scrapyards and mills. Waste becomes raw material for transformation. Collected loads move to centralized sorting.
Transport links reclaimed wood streams.
Across regions, millions of tons move toward recycling plants.
Here, wood waste from construction and demolition joins the stream.
Human coordination guides every movement.
Classification begins at the source.
Flow must remain continuous.
Metal contaminants challenge production integrity.
Nothing can enter the grinder unchecked.
Machines isolate what hands cannot. Foreign metals must be removed before size reduction. Only purified timber may continue. Uniform sizing eases downstream processing. The first reduction stage begins. From discarded scrap, controlled transformation starts here. Freshly shredded fragments await bulk transport. Every load pushes the cycle forward. Precise handling protects downstream flow rates. Capacity reached. Secure the load. Containment prevents airborne loss during transport. Bulk flow requires coordinated logistics.
Each load precisely documented.
Destination: MDF production facility. A new form awaits the recycled fiber. Energy and automation converge here. Every gram accounted to balance production cost.
Precision reduces collisions and delay.
Gravity assists bulk discharge. Wood transitions from transport to internal flow. Intermediate storage balances processing demand. Sensors monitor fill height and density. Even feed is critical for fiber uniformity. The journey enters the heart of the facility. At full scale, recycling becomes industrial mastery.
Enormous heat awaits inside.
Safety begins before the first machine powers on.
Only authorized personnel may proceed.
Contamination threatens precision fiber formation.
Material enters controlled industrial flow.
Routing determines the order of transformation. Every metric controls stability.
Next step, impurities removed before refinement. Mechanical and pneumatic sorting work in tandem. Particle size influences fiber bonding strength. Air lifts the lightest fragments away. Final cleaning before reduction. Reduction refines feed into fiber-sized particles. Mechanical force reshapes broken wood. Uniformity prepares the path for drying. Drying begins the controlled reduction of moisture. Precision measurements guide airflow modulation. Uniformity defines ultimate board strength. Evaporation accelerates in turbulence. Unwanted discoloration signals impurity. Only acceptable fiber fragments remain. Airborne transport supports flow control.
Centrifugal force isolates density differences.
Downward discharge continues refining pathway.
Absolute purity prevents grinder damage.
Precision guarantees even resin mixing. Transformation intensifies.
Consistent flow sustains production rhythm.
The material becomes unrecognizably transformed.
Airborne particulates threaten worker safety.
Collected fines will be reintegrated later.
Purified material approaches resin bond integration.
Air fibers gain the adhesive strength required for panel formation. Adhesive resin binds every fiber into future structure. Wax strengthens dimensional stability. Uniform dispersion prevents weak spots. Real-time monitoring ensures consistency. Flow corrections maintain fiber mat integrity. A panel begins as a delicate cloud settling into order. Controlled layering builds uniform strength. Nothing wasted. Excess returns upstream. Gentle pressing readies the mat for extreme force. Accuracy safeguards target specifications. Alignment prevents edge deformation downstream. Heat prepares adhesive for polymerization. The moment of conversion approaches. Pressure and heat birth dense composite form. Moisture flashes to vapor as resin polymerizes. Precise cure time locks internal bonds. Cooling stabilizes the hardened structure for finishing. Cooling locks internal resin crosslinks. Thermal shock is carefully avoided. Thermal shock is carefully avoided. Precision handling preserves edge integrity.
Feedback systems maintain accuracy.
Equilibrium prevents warping. Controlled rest strengthens internal fiber cohesion.
Raw boards move toward dimensional calibration.
Exact lengths reduce waste in downstream use. Edges trimmed to engineered tolerance. Micrometer tolerances define quality. Surface refinement prepares for finishing. Efficiency increases throughput. Automation handles weight precisely. Boards must rest before final finishing.
Stacking prevents deformation.
Preparation begins for final trimming and grading. The boards roll onward to precision finishing systems. Robotic precision accelerates the finishing phase. Automation ensures constant throughput. Each panel enters precision surface preparation.
Surface consistency required for bondable finish.
Dust captured and recycled within process streams.
Edge sealing prevents moisture absorption.
Traceability links every board to its origin. Instant cure speeds line flow. Computer vision identifies micro imperfections.
Decisions feed automated correction.
Precision blades remove imperfections. Dimensional accuracy ensures downstream compatibility. Sorting aligns product quality with specification. Automation maintains precise order across the line. Final polish prepares boards for surface coating. Clean surfaces ensure strong adhesion.
Surface sealing protects from moisture and warp.
Heat accelerates coating polymerization for durability. Final dimensions must meet exact tolerances. Calibration systems guide precision saw control.
Inspection exposes even the smallest flaw.
Imperfections sealed to perfection.
Final touches secure lasting durability. Edges shaped for seamless installation. Positioning prevents surface abrasion.
Automated stacking organizes outbound flow.
Sensors maintain uniform stability.
Precision timing synchronizes movement.
Material flow moves toward packaging. Stability maintained under load. Exact positioning prevents wrapping faults. Protection prepares boards for inspection and delivery.
Only verified boards exit the production line.
Tracking assures traceable history. Random sampling drives statistical accuracy. Environmental control prevents contamination. Representative samples reflect batch integrity. Dimensions must remain within strict tolerance. Hardness determines long-term wear performance. Bond strength reveals fiber resin cohesion quality. Boards must resist swelling under moisture exposure. Boards must resist swelling under moisture exposure. Sound waves reveal hidden density variations. Dimensional stability under heat prevents warp.
Fire rating defines safety compliance.
Air quality standards safeguard human health.
Quality controlled through rigorous evaluation.
Only certified boards progress to dispatch. Identification completes quality chain.
Now the certified product enters distribution flow.
The final journey begins toward package dispatch.
The finished boards enter controlled storage. Secure placement protects delicate coatings. Digital tracking ensures fast retrieval.
Demand triggers outbound logistics.
A journey toward installation begins. Boards transition to outbound staging. Every pallet undergoes final checks. Secure packaging resists transit stress. Transport synchronization enables load transfer. A seamless path connects factory to fleet. Load stability protects product integrity. Protection prevents shifting in transit.
Final preparations for departure.
Distribution begins across regions. Recycled wood transformed through precision engineering. A circular economy in motion. From waste wood to engineered boards with purpose.
And this is how modern factories produce MDF boards from recycled wood, start to finish. Subscribe for more real factory breakdowns.